Today I will be doing the 2022 Practice Exam 3 MCQ for Physics 1, and I'll be doing questions 1 through 10 in this video. So the first question, we have a 4 kilogram box moving to the left and a 3 kilogram box moving to the right. It says that they collide and it asks us what the motion of the boxes after the collision will be. Well, to find the motion of the collision, we have to find momentum. So we know momentum is equal to mv. However, it doesn't give us a velocity for either of the objects, so the motion cannot be determined for the collision after the collision, so our answer is D. Moving on to number 2. Number 2, there's a brother and a sister standing on ice, and the sister pushes the brother and moves with kinetic energy is equal to K. So the first thing we have to do is find the momentum of the brother. So the momentum of the brother, as I just said, the last problem, is equal to P and V. So the momentum of the sister, we'll say, is equal to M V0. Well, we know momentum is conserved always, so her brother's momentum is going to be P 2M Gx, and this is going to be equal to PS. So Vx is going to be equal to whatever the ratio of V to Vx is. So to find that, we just plug the 2 in, then we're going to get mv0 is equal to 2mvx, and then just we get that, take out those terms. Vx is equal to 1/2 v0. Now we put this back into the kinetic energy equation. So the brother's kinetic energy, Ke 1/2 2m v over 2 squared. So these two cancel out, so we're going to get kinetic energy is equal to v squared over 4, which is going to be, and the system momentum is going to be Ke is equal to 1/2 mv squared. Our ratio here is going to be 1 to 2, so the brother's kinetic energy is equal to K over 2, so our answer is C. Right, moving on to question 3. Question 3 asks for the range and position of the cart. T equals 0, position is equal to 10, and velocity is equal to -3, and our acceleration has a positive acceleration with magnitude 3 less than acceleration less than or equal to 6. Or just actually it's just less than. It doesn't matter. So all we have to do here is a kinetics equation. X equal x initial plus v initial t plus 1/2 acceleration t squared. So let's do for 3 first. 3, we're just going to get 10 plus -3 times 1 plus 1/2 3 1. It is asking for the position after 1 second, so combine those all together, we're just going to get 7 plus 3/2, which is equal to 8.5 in decimal form. So we know 8.5 is our threshold. And then if we just look at the answers, there's only one 8.5, so we know the answer is B. Moving on to number 4. Number 4 asks for the forces exerted between the launcher and a block. So here we have a thing hanging from the launcher, hanging from looks like a rope from the ceiling, and there's a spring in a box, and the box gets pushed back like this, and it's going to shoot back out. So it asks, which of the following statements is true about the forces between the blocks? A, the launcher exerts a greater force on the block. B, the block exerts a greater force on the launcher. C, the block and launcher exert forces equal magnitude. Or D, the relative magnitude of the forces exerted on the spring by the block and launcher cannot be determined without knowing V1 and V2. Well, the answer here is just C. This is due to Newton's third law. Every action has an equal and opposite reaction, so that one's relatively easy. Number 5, we have net force from a graph of potential energy. So we have this graph here, and it looks something like B, and we have 0 is equal to H. Here's J, L, and then M. This is potential energy in joules, and this is displacement. Or it's just the x-axis. So it asks us for in which segment does the net force exerted on the object have the greatest magnitude? So in the question, it gives us mechanical energy is equal to 5 joules. So in which segment does the net force exerted on the object have the greatest magnitude? All we have to do is just find where the kinetic energy is the highest or the lowest, because we know delta energy is equal to the change in work. Oh no, it's just equal to work. F times distance is parallel to force. So the greatest net force is going to be between the two adjacent points at the greatest magnitude of change. The greatest magnitude of change is right here, makes the biggest change. Right here on the graph, it actually gives us this is 5, and this is 2, and it makes it in just one letter instead of right here. It makes 4, and there's another letter here, there's an I. So we know that the greatest change is just Lm. So our answer for this one is D. Moving on to question 6. Question 6, we have kinetic energy from the graph of potential energy again. So it asks us what is the kinetic energy of the object at point K. So we know mechanical energy is equal to 5 joules. So we just have to find what the potential energy on the graph is for K. It says it's 2. And we know mechanical energy is equal to kinetic energy plus potential. So we know 5 minus 5 is equal to kinetic energy plus 2. So we know the kinetic energy at point K is equal to 3. That's a bad 3, but you get it. So our answer for that question is going to be C. Question number 7 is again the exact same thing, exact same graph, but it asks us which of the following describes the magnitude of momentum of the object in the first two straight line segments shown in the graph. So it asks us for IH and IJ. So what we need here is we're going to want to find the kinetic energy, because kinetic energy we know has velocity in there, and so does momentum. A lot of the time kinetic energy and momentum are used together a lot. So we know the total mechanical energy of the system is 5, and it gives us HI. The potential energy from HI is 4. So we know we have 1 joule of kinetic energy between HI. So we know that it's moving, so we know that the velocity is going to be constant. So we can rule out A and B, because HI is going to have a constant but non-zero velocity. And now all we have to find is whether IJ is increasing or decreasing. Well, between I and J, we can see that the overall potential energy goes down. So we know that means that kinetic energy goes up. It's an inverse relationship. Therefore, we can conclude that the velocity increases because mass won't increase unless you're doing something crazy. It's just assumed that velocity is changing always. So we can now see that ij is increasing and that ij is constant. So our answer is C. This is not working. Now, moving on to question number 8. Question number 8 asks for the moving object changing direction. That is what it's titled. So it gives us at time equals 0 an object is moving to the right with a velocity v is equal to 4.2 meters per second minus 1.4 meters per second squared. So here, all we have to do is find when v is equal to 0. So we just get 0 is equal to 4.2 minus 1.4 t. Just put 4.2 to the other side. Negative 4.2 is equal to negative 1.4 t. Negative 1.4 t, 4.2. That's just 3. So we get the answer. 3 is equal to our time, so that's when it's going to change. If you're already asking, where do you get the t from? Well, if I keep it all in respect to velocity, this would just be the same as y is equal to b plus mx. Because acceleration, we know it's the derivative, so it's going to have a t in there to keep it in the same terms as velocity. Yeah, that probably doesn't make much sense, but it's how it works. Question number 9 asks us for torques exerted on two objects. So for this one, I did a little mini proof for it. So torque is going to be equal to d dt of our angular momenta vector. So if we just find the magnitudes of angular momentum and just find what that is and take it in respect to time, we're going to be equal to torque. We can also use the equation, well, this is just going to be equal to the slope of angular momentum. So for torque, we get change in L is equal to torque times change in T. You can just take this, change in T is equal to torque. So the change in angular momentum of object X in respect to time, we have it changing from 10 to 0 in 5 seconds. So d dt angular momentum X is going to be equal to 10 minus 0, 5 minus 0, which is equal to 2. So we know that's what our torque is, and d dt, or angular momentum of the second one, for y is, it changes 20 in 5 seconds. 20 minus 0, 5 minus 0 is equal to 4. 4 is equal to 2 times 2. So our answer is the torque of y is equal to 2 torque x in magnitude. That's not the right tool. All right, question 10. Question 10 has an inclined plane. That's not a very good inclined plane. That's better. With two boxes moving each other with the same velocity and same mass. So what this question asks for is the center of mass and how it's moving. And it gives us an x-axis up here, x is divided as this, and y positive is that. That is not supposed to be a t, that's supposed to be positive. So it asks for how the center of mass velocity of the two-block system is changing. it might just seem that, oh, they move at the same velocity, the same pace, that, oh, it's just going to go here. It's going to be constant and non-zero, constant and zero. However, that's wrong, because if you look at it, there's force pulling down on both blocks in this direction because of gravity. We can find that these are going to have two things, x product and a y product. So we know that they're being pulled down, and this is the x direction, x positive direction, and they're both being pulled positively x. If you look here, our horizontal acceleration is pointing to the positive. Therefore, we can see that the answer is going to be D, that the center of the mass of velocity, the center of mass velocity of the two-block system is increasing in the x plus direction.